Hi everyone, welcome to my YouTube channel, and in this video we will talk about the unit cell and coordination number. This is basically an extension of my previous lecture in which I talked about crystalline and amorphous materials, just briefly telling that crystalline materials are those in which the atoms have arranged themselves in a certain structure, and then this structure keep on repeating itself in the long range in order to form the overall structure. However, in the amorphous materials, we lack such a long range structure. So basically, what a unit cell is, the unit cell is the smallest repeating unit or the basic building block of a whole structure. These smallest building blocks or the repeating units tends to arrange themselves in the long range in order to form the overall structure of a material. For example, if you see the example of a home or a wall, the basically we can see that it's a brick, a single brick, and then the different bricks are just joining with each other in order to form the overall structure of a wall. So in this case, the brick is basically the simple unit cell which is making the whole wall. If you see another example, I have shown this image in my previous lecture as well, a typical structure of a silica in which silicon and oxygen atoms has been arranged themselves in a certain structure, and then this structure has been repeating itself into the three dimension in order to form the whole structure of a glass, of a crystalline material. Not the glass, because glass is basically an amorphous material. Besides unit cell, coordination number is basically an important term that we use in crystallography, and coordination number means that the number of atoms, molecules or ions which are bonded to the central atom in any structure. So the number of atoms which are very close or they're making bond basically with the central atom defines the coordination number. These coordination number are the structure of the unit cell. Basically, is responsible for many properties of a certain material, and we will see that the atoms in each metal or in each crystalline material arrange themselves can arrange themselves in different ways, and that's basically the unit cell is all about. So starting from the one of the most simplest way in which atoms can arrange, and it's called simple cubic. As you all know how the cube look like. So in this structure, the atoms which I have shown like that spheres are present at each corner of the sphere. A sphere has typically 8 corners, so there are 8 atoms and they are present at each corner of the sphere. And then this repeating unit, which is a simple cubic, extends itself in 3 dimensions to form the overall structure, as you can see here. Now, when we have to calculate the total number of atoms per unit cell, we have to see that it's not 8. Although we can see that there are 8 number of atoms which are present in each unit cell and they are present at each corner. However, if we see the cross section, it's not a complete atom which is present in each repeating unit. Single atom is contributing basically the 8 different repeating units. As we can see in this image, one of them is this repeating this sphere or this cube, sorry. One is on the left side, one is at, if I see this atom, so it is basically contributing one to this cube, once to the cube which is on the left side, one cube on the top. Then there would be one cube which is top of this left cube. So this, then we have 4 different cubes. Similarly, when we have the 3D, there will be 4 different cubes which are present in front of these cubes. So in total, this atom is contributing to the corner of 8 different cubes. And then when we calculate how many atoms a single unit cell is, then we have to divide, or we have to take only 1/8 of each atom at each corner. So the number of atoms which are present per unit cell in the simple cubic are 8, and then 1/8 of each. So basically it gives us the value of 1. So simple cubic materials in this, the materials in this structure has one atom per unit cell. The coordination number of atom in this simple cubic structure is 6. The atoms are all the positions in this structure are totally equivalent to the other one, and here we can see that each atom has 6 neighboring atoms. Again, if I take the example of this atom, we can see that one is on the right side, when one would be on the left, one on the back, one on the top, one on the bottom, and one on the front. So in this way, we have the coordination number of 6, and it would be same for all of them. This simple cubic structure is basically not a very dense structure, and uh, it's very rare that the metals have such a structure. There's only one example that we have seen as in case of polonium, which shows the simple cubic structure. If we go to the other example and the other types of crystalline structure, it is called body center cubic structure. So it is basically again the cube, as we have seen in the previous slide, but in addition to the atoms which are present only at the corner of each cube, we have seen additional atom which is present right in the center of each cube. And this you can see more clearly over here, that there is one atom which is present at the center of each repeating unit. And this atom is basically not contributing to any other one. So each repeating unit has its own one atom which is present right in the center of the cube. In this case, when we have to see the total number of atoms per unit cell, we have again 1/8 contribution coming from the corner. So basically 1 atom per unit cell which is from the corner. And in addition to that, we have to see that each repeating unit has one atom in the center. So here in the case of body center cubic, we have basically 2 atoms per unit cell, one from the center and one complete atom coming from the center of each cube. The coordination number in this case is 8. As we can see that the central atom, we can clearly see that the atom present in the center has 8 atoms which are present. Like the atoms which are present at the center, they are defining the coordination number of the central atom. We have seen many metals. We can see there are typically many examples, for example, chromium, iron, tungsten, and many more, who have the body central cubic structure. The third type is face center cubic structure, and in this case, we have again we take the example of a simple cube in which the atoms are present right at each corner of the cube, and in addition to that, we have see that there is one atom present at each face of the cube. In this case, we don't have any atom which is present right in the center of the cube, like we have seen in the case of body central cubic. So in this case, when we see the total number of atoms per unit cell, we have 1/8 from each corner. So basically 1 atom coming from the corner, just similar to what we have seen in the previous examples of simple cubic, while we have the 3 atoms which are coming from the face. Now, since there's 1 atom present at each face, and then this atom is contributing to 2 different repeating units. So we'll take half of atom per unit cell from each face. So basically, since there are 6 different faces of a cubic structure, and from each face there would be a half atom. So in total, we have 3 atoms coming from the faces. So when we see the total number of atoms per unit cell of a face under cubic, it would be total number of atoms would be 4. The coordination number in this case is 12. And for this, we can see that we can take the example of a central atom which is present at a face, and we can see that 4 atoms are present at each corner which are close, and 4 of atoms are present into the faces, like not the top one but on the right and left and front and back. And similarly there would be four atoms which are present again in the lower repeating unit, which are present in the faces, like on the right, left, back and front face. So the total number of atoms, total number of the coordination number in this case is 12. The typical examples of metals that have face-centered cubic structure are is copper, aluminum, silver, and gold. Here you can see more clearly how the face atom is basically half of atom is present at each repeating unit. Well, the atoms in the metals are not only arranging themselves into the cubic structure, but there's another form which is called hexagonal closed pack structure. And in this we have a crystalline structure which is slightly different than the cubic structure. And we can see that there are two faces, and each face has like the top face and the bottom face, and each face has six atoms which are present at each corner. Other than this, we have two atoms which are present only at the top and the bottom faces, and they are present right in the center. And beside these atoms, we have also three atoms which are present into the interior planes, and these atoms are again not contributing to the any other neighboring unit cell. In this case, to calculate the number of atoms per unit cell, we have to see that since there are 12 number of atoms in the top and the bottom face, 6 in each, and each atom is bonded to the or contributing the 6 different repeating units. So only 1/6 is coming into the one basic unit cell. So in this way, if we see the top and bottom faces, excluding the central atoms, there are total only 2 number of complete atoms which are present per unit cell. For the atoms which are present at the center of the face, so there are basically 2 atoms, and again like in the face central, here also half of the atom is coming per unit cell. So in total, half from the top and half from the bottom. So basically 1 atom per unit cell is coming from the center of these faces. And we will take the 3 atoms as it is from the interior plane because they are not contributing to the neighboring repeating units. So if when we calculate the total number of atoms per unit cell in hexagonal closed pack structure are 6. In this case, also the coordination number is similar to the what we have seen in the previous slide for the face center cubic. And we can see that if we take the example of this central atom, there are 6 atoms which are coming from this face, 3 atoms from the interior plane, and also 3 atoms from the interior plane from the unit cell which is present below it. So basically the coordination number in this case is also 6. And coordination number defines also how dense the structure would be. Higher the coordination number, the more density it would be, and we will see in the next lectures how to calculate basically the density of each type of crystal structure. That's all, and in the end I have just write down a summary in the form of table in which I have shown the different type of repeating units, the structure of repeating units, and the atoms per unit cell, and their respective coordination. Thanks a lot for your time, and in case of any questions, kindly let me know by commenting below, or you can write me directly on the emails, and I would love to answer all of your queries. Thanks a lot.